I'm going to go over the problems in the Unit 1 review that involve using the calculator. Number 1 is just reviewing some terminology, so make sure that you can identify and understand those terms. Number 2 is drawing a Pareto chart. So just make sure that you know the mode here is Ford, because that's the most frequent car. And so you put that first in your Pareto chart. A Pareto chart, of course, is the vertical bar chart that shows these categories in descending order. So Ford would go first, and then the Hyundai, and then the Honda, the VW, and the BMW. Answers to this review are at the bottom of the review, so you can see what the Pareto chart looks like. Number 3, this one involves data for sections, of course, and it's asking for this population, meaning that's all of the sections. Find the mean, median, mode, range, and standard deviation. So this one, you definitely want to go to your calculator, turn it on, of course, if it's not on already, and go to your Stat button, enter for edit, and then if there's anything in your list, go ahead and clear that out. I'm going to arrow up and hit clear and enter for list 2, and arrow over and up to hit clear and enter to clear list 1. Now I only need one list for a single set of data. So I'm going to use list 1. You just type in the data, 31, enter, 26, enter, 28, enter, 25, enter, 30, enter, 29, enter, 30, enter, 31, enter, 30, enter, 27, enter, 31, enter. And always double check when you type in data, always proofread your data, make sure you didn't make any typos. You can arrow up and scroll up through the list of data, make sure that there are no typos, because that's one of the biggest sources of error and getting problems wrong on a stats test. All right, so I'm pretty sure I've got all those in there correctly. And actually, you can see when my cursor is on L1 that it just lists the whole list. When it's on a single value, it just lists that value. And there's a list, count 1 first item, list 1 second item, and so on. All right, so to find most of these parameters, you just go to Stats and over to the Calculate menu and hit Enter for one variable statistics, and then tell it to use list 1. Now, if your calculator brings up an extra screen here, then make sure that it selects list 1 for the data and that the frequency list is blank. So it's just using list 1. And then hit Enter. X bar is the notation that the calculator uses for the mean. That's technically sample mean, but it's population mean in our case as well, 28.909 to 3 decimal places. The min you have to scroll down for. The median is 30. The mode is not given because it's a function. There may be more than one, there may not be any one. So we'll have to go back to the list to see the mode. The range is the difference between the min and the max. So we can scroll down and see the min and the max, subtract the maximum value minus the minimum value, 31 minus 25, and that gives you 6 for the range. The standard deviation is one of the reasons we really need to use the calculator for these. That's the one with the fancy formula, and that's also the one that depends whether it's a population or a sample. The calculator uses S, In fact, we, in practice, just use S for a sample standard deviation, a standard deviation of sample data. This says it's a population, so we want this lowercase Greek s called a sigma. The sigma of the x's, the population standard deviation. This is the one we want here, and that would be 2.021 rounded to the third decimal place. Just remember, we don't need everything the calculator shows here. The sum of the x's, the sum of the squares of the x's, those second and third things we don't need. We need the mean, we need the standard deviations. Sometimes we need the number of data values. There are 11 values there. You can double check that too. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 data values. Scroll down with the arrow keys and you get your 5-number summary. The minimum, the first quartile, the median, which is the second quartile, the third quartile, and the maximum. And then you can get your range. Now for the mode, we want to sort the list of data. So go back to Stat, arrow down to Sort A for ascending, D for descending. I'll choose Sort A. Hit Enter. And then we have to tell it to use list 1. So second one tells it to use list 1. You can just hit Enter. And it says Done. So you go back to Stat, Enter for Edit to see the list. It's all sorted in numerical order. Now we can see where there's repetition, so we can find the mode, the value or values that is or are repeated the most. You can see there's 3 30s and 3 31s. So there are 2 modes, 30 and 31. And again, the answers are all at the bottom of this document, so you can double check and practice as you go. Number 4 is a weighted mean. It says in one class, 20% of a student's grade will come from each of 3 tests, 15% from computer activities, and 25% from final exam. What will be the student's average or mean if he receives 75, 89, and 82 on the test, 95 on the computer activities, and 79 on the final exam? So here's where we want to use 2 lists. So back to Stat and Enter. Of course, I was already there, but now I need to clear out list 1, arrow up, clear, and Enter, and make sure list 2 is also clear. List 1 is where we want to put the data values, which are the grades, 75, 89, and 82 on the tests, and then 95 on the computer activities, and 79 on the final exam. Then list 2, arrow to the right, we want to put the what are those grades, the percentages, and you can put them either as a decimal or as a whole number percent. I'll just use the whole number percent. Each test is worth 20%, so we want to put 20 in list 2 next to the 3 tests, and then the computer activity is 15%, so that goes next across from the grade for the computer activity, and then the final exam is 25%, so that goes last. Do not sort either one of these lists, and make sure that that's paired up the way it should be. Then you go to Stat, Calculate, one variable Stats, and now we need to tell it to use both lists. Make sure you don't just hit Enter, or it will only use list 1. So you have to tell it to use list 1, second one together with list 2. Comma has to go between those, the comma of the number 7 key, and then list 2. Now if your calculator has an extra screen that comes up asking where the list is and where the frequency list is, then you will just tell it to use list 1 and list 2 for the data list and the frequency list. Then hit Enter, and X bar, as usual, is the mean or average of that data. So that gives the average grade weighted by those percentages, 83.2. Here's where also you could give a standard deviation if they asked for it, for a frequency distribution or weighted grade. But this one just wanted 83.2. Number 5, you want to go back over the Chebyshev theorem and empirical rule. Make sure you know the numbers in those theorems, those facts. Chebyshev's theorem says 8/9 or about 89% of the data will fall between what and what. That theorem says that that's the percent that will fall within 3 standard deviations. So you would take the 3 standard deviations of the mean. So you would take the mean of 74 and add the standard deviation 3 times and subtract it 3 times to see what those values would be. So the mean plus 3 times the standard deviation would be the quick way to add it 3 times. Would be the upper number. And the mean minus 3 standard deviations, 3 times 4.8, would be the lower number. And again, if you wanted to, you could take the mean and actually physically subtract the standard deviation 3 times to get the value that's 3 standard deviations below the mean either way. So 59.6 to 88.4. The empirical rule, you want to make sure that you remember that that's talking about bell-shaped distributions, which this is, and the percentage that falls between 64.4 and 83.6, you have to first figure out how many standard deviations that is from the mean. If you take the mean plus 1 standard deviation, 4.8, that gives you 78.8. That's not one of those numbers, so add it again. Add another standard deviation. And let's see, 83.6, that's that upper number. And I bet this lower number, 64.4, is what you get when you take the mean minus 2 standard deviations. 2 times 4.8. 2 standard deviations below the mean, sure enough, is 64.4. So these are the numbers that are 2 standard deviations below and above the mean. What does the empirical rule say about that? That you need to memorize. Empirical rule says 68% falls within 1 standard deviation of the mean, 95% falls within 2, and 99.7% falls within 3 standard deviations of the mean. So this is talking about the 95%. The z-score formula is one of the few formulas you need to memorize, but it's simple. To find a z-score, you take the raw score that you want to convert or standardize, in this case 85, subtract the mean, which is 74 in this case, hit enter, put that in parentheses because you need to subtract that first, and then divide by the standard deviation. So it gives the distance from the mean in terms of standard deviations. So 85 is 2.29 standard deviations above the mean. For 60, basically, again, take 60 minus the mean. This one comes out negative because 60 is below the mean. Divide by the standard deviation, 4.8. And you see the z-score for 60 is negative 2.92 rounded, or 917 to the 3rd decimal place, depending on what they ask for. So that value is almost 3 standard deviations below the mean. All right, number 6. Here, we need to fill in the midpoints, the relative frequencies, and the cumulative frequencies for this frequency distribution. The midpoints, clear this, are the middle values between the lower class limit and the upper class limit. So you take the lower class limit for the first class, add the upper class limit, 4, 4.0, hit enter, or put that in parentheses, and divide by 2, basically averaging those. 2.05 is the first midpoint. And then you can do that for the next class as well, or notice that the class width here is 4. The lower limits are all 4 apart, and the upper class limits are all 4 apart. So the midpoints have to be 4 apart. So the next midpoint would be 6.05, right? Just adding 4. In fact, I can even physically do that. Say, all right, well, what's that plus 4? And get the next midpoint. In fact, then you can just hit enter, and it'll do it again for you and again. And those are the midpoints. The relative frequencies you can get by dividing the frequencies by the total. So here you would have to first add the frequencies together. 7 plus 50. Oops. 7. Typo. Watch for those. 7 plus 50 plus 73 plus 48 plus 22. We have a total sample size of 200. Notice it does say it's a sample. So the relative frequencies are going to be each of these frequencies divided by 200, basically how big each class is relative to the whole. There is a trick for doing that. You can divide each frequency by the total separately, or you can go into your list. Let me go up here and show you. I'm going to use list 2 for the frequencies here. 7, 50, 73, 48, and 22. And then if I use list 3 for the relative frequencies, I can just divide each of those 200, or I can do this trick where I arrow up to the list 3 title and tell it to define list 3 in terms of list 2 by taking list 2, second 2, and dividing that whole list by 200. So again, notice that my cursor is up on L3. It's not in L3, it's actually defining this list. At the bottom it should say just list 3 equals list 2 divided by 200. And then when you hit enter, voila, it shows all of those divided by 200. So those are the relative frequencies, which you can then change to percentages by moving the decimal place over 2 places. The cumulative frequencies then are what you get when you cumulatively add the frequencies. The first one is the first frequency of 7. The second one, you add the next frequency of 50 to get 57. And then you add the next frequency, which is 73. In fact, you can do that right here. You can take 57 plus 73. 130, and then you want to add 40. So 130 plus 48 gives you the next cumulative frequency, and then you get by adding 22, and it should always be the total, that last cumulative frequency. All right, part B of this asks how many scores, so that's the 200. And then part C asks for the mean and standard deviation of this sample. We've got the relative cumulative frequencies, and you can look at the answer key for the relative frequency histogram. To get the mean and standard deviation, here is where you need to use the midpoints as representatives of the data, because we don't know what the actual distance is. We just know how many of them are in each class. So we use the midpoints as representatives. Let me put those into list 1. Clear out these old numbers from list 1. Arrow up, clear, enter. Those midpoints, if you remember, were 2.05, middle of the first class, 6.05, 10.05, 14.05, and 18.05. Where did I get 20? All right, so double check. We've got the midpoints in list 1 and the frequencies in list 2. That's what you want to have to get mean and standard deviation from a frequency distribution. Midpoints in list 1, frequencies in list 2. Then you go to your stats, over to calculate, one statistics, and just like the weighted mean, this is where you need to tell it to use list 1 for the data. That's the midpoints in this case, and then comma, unless you have that extra screen that asks for the frequency list, and tell it to use list 2 for the frequencies, and then enter. And there's your mean, 10.61, and the standard deviation depends on whether it's a sample or population. This one's a sample. We want S. 4.1098 actually rounds to 4.110. I will do the rest of the problems in this review in a separate video.